Hi everyone, we are from Group 9 and today we are going to teach systems of linear equations. Our group consists of me, Josh, and Mirza, Adam, Zinzir, Zafri, and Akash. So basically, a system of linear equations consists of multiple equations that have terms with constant values preceding them, and the summation of the terms equates to a constant as well. A series of equations forms the system of linear equations. There is predefined solution for the system. In case of the system of equation is a11x1 plus a12x2 plus all the way till a1n xn equals to b1, then the solution is x1, x2, x3 and all the way till xn, and there's no limit for n as long as n is a real value. The solutions that we obtain have to satisfy each of the equations that makes up the system of linear equations. Then there are 4 different methods to solve system of linear equations. These 4 different methods will be taught soon. There are 2 types of linear equation systems. As for the method of solutions, the 4 methods are Gauss elimination method and Gauss-Jordan elimination method, which uses elementary row operations, and then there are also inverse matrix method and then Cramer's rule, which uses matrix methods. This will be explained further later on. And as for the types of system of linear equations, the 2 types are homogeneous system and non-homogeneous system. Basically, the matrix from the system of linear equations multiplied by the solutions equals to 0 if the system of linear equation is homogeneous. And if it doesn't equal to 0 or if it equals to a constant value, then it is a non-homogeneous system. And that is all from me. I will pass on to the next section, which is Gauss elimination method. Thank you.
The first method on how to solve linear equation using matrix is by using Gaussian elimination method. In this method, it consists of 3 steps, which is constructing the augmented matrix using ERO to transform the matrix from the augmented matrix form to its echelon matrix, solving using substitution. So we are given 3 equations, which is x1, x2, and 2x3 is equal to 9, 2x1 plus 4x2 minus 3x3 is equal to 1, 3x1 plus 6x2 minus 5x3 is equal to 0. From this equation, we're going to transform it into matrix and then we're going to make it into augmented matrix. How to do that? First, we're going to transform this equation into matrix form, which is ax is equal to b, where a is equal to the coefficient of x1, x2, and x3, which is 1, 1, 2, 2, 4, negative 3, 3, 6, negative 5. X is equal to x1, x2, and x3, and b is equal to 9, 1, 0. So in order to make an augmented matrix, we're going to take a into the left side of the augmented matrix and b onto the right hand side of the augmented matrix. So the next step, we're going to transfer the augmented matrix into an echelon matrix using elementary row operation, ERO. So by using ERO, we're going to find the leading one for each row in the matrix. So here, as you can see, we already have the leading one for the first row, which is this one. As a result, we're going to use this row as the reference to get the leading one for the lower row, which is second row and the third row. The first step here, we're going to find the leading one for the second row, where we will minus R2 with R3, and then afterward, we're going to make it negative. So we will get 1, 2, negative 2, negative 1. Here you can see we already have number 1 here, but this is not a leading one for the second row. Why? Because as you recall back in to the row echelon matrices properties, it says the leading one in the lower row occurs farther to the right than the leading one in the upper row. So that means this one cannot be the same column with the leading one of upper row, this one. So in order to make it right, we're going to minus the second row with R1, so that we're going to have 0, 1, -4, -10. This one is what we call leading one because it is placed farther to the right than the upper leading one. Same goes to the third row. We're going to find the leading one by minus 3R1 and minus 3R2 on the third row. So we will get 0, 0, 1, 3. As a result, we already have this echelon matrix 1, 1, 2, 9, 0, 1, -4, -10, 0, 0, 1, 3. From the echelon matrix, we're going to convert it into equation form where we will get x1 plus x2 plus 2x3 is equal to 9, x2 is equal to -4, x3 is equal to -10, x3 is equal to 3. As you can see here, we already have the value for x3. By using this value, we're going to substitute it into the first two equations, and we will get x1 plus x2 is equal to 3, x2 is equal to 2. You can see here, we already have the value for x2. So we're going to substitute it to the first equation where we will get x1 is equal to 1. Eventually, we already solved the linear equation where the answer is x1 is equal to 1, x2 is equal to 2, x3 is equal to 3. So that's all for the Gaussian elimination method. Next, we're going to show you how to use Gaussian Jordan elimination method.
So I will continue to the next step of solving simultaneous equation by using matrix. So the next step is using Gauss-Jordan elimination method. So Gauss-Jordan elimination is a method to solve a system of linear equations using elementary row operation or ERO. So basically, Gauss-Jordan elimination is just the same as the Gauss elimination method. But for this method, we need to further on the reducing part until we get the REM and not just the REM. So it consists of 3 steps, which are constructing the augmented matrix, and next using ERO to transform the matrix from the augmented form into its echelon matrix. So like I said just now, we need to solve by finding the row reduced echelon matrix, which is REM. So here we can look at this example to get further understanding about this Gauss-Jordan method. So here we have a system of equation which having a 3 unknown which are x1, x2 and x3. So for the first step, you need to transform this equation into the matrix form, and we can change the matrix form into the augmented matrix form, like you can see just here, which is 1, 1, 2, 2, 4, -3 and 3, 6, -5. So this value is taken by the coefficient of simultaneous equation, and for the right part is 9, 1, 0, also taken from the equation. So after that, we can transform the matrix into the echelon matrix by using ERO. So what I did, I used row 2 minus 2 times row 1, so that the row 2 will be changed into 0, 2, -7 and -17, and the others will be the same. And the next is row 3 minus 3 times row 1, so the row 3 will be changed into 0, 3, -11 and -37. And for the next step, I use row 2 minus row 3, and by looking at this matrix, we know that 2 minus 3 is equal to -1. So we must get the middle one is only +1. So I times the row 2 minus row 3 times with -1. So the row 2 for the next form of our augmented matrix is 0, 1, -4 and -10. And then I minus row 3 with 3 times row 2. And then I will get 1, 1, 2, 0, 1, -4, 0, 0, 1. And for the right side is 9, -10, 3. So what we get here is the echelon matrix. So because we are using the Gauss-Jordan elimination method, so we need to further on the reducing part. So what I did is I minus row 1 with row 2, and the row 1 will be changed to 1, 0, 6 and 19. And to get rid of 6, I use row 1 minus 6 times row 3, and the row 1 will be changed to 1, 0, 0, 1. And for the last, we need to get rid of the negative 4, so I use row 2 plus with 4 times row 3. And at last I will get 1, 0, 0, 0, 1, 0, 0, 0, 1, and for the right side is 1, 2, 3. So here we have the RREM. So by observing this matrix, we can observe that each row only have the one unknown, which are non-zero. Like for the row 1 we get x1, and for the row 2 we get x2, and for the row 3 we get x3. So by looking at this, just simply we can determine the value of x1, which is x1 equal to 1, x2 equal to 2, and x3 equal to 3. So here we get the answer of the unknown. That's all for me.
Inverse matrix method. Inverse matrix method is a method to solve system of linear equations. It consists of 5 steps. Step 1. Convert the matrix form by finding the determinant and ensuring it is not 0. Step 2. Finding the cofactor of the matrix. Step 3. Finding the adjoint of the cofactor. Step 4. Finding the inverse matrix by multiplying adjoint and inverse determinant. Step 5. Solve by finding the product of inverse matrix and RHS matrix. Given the following set of system equations, the equation Ax equal to b is shown below. The determinant of matrix A is converted by the following steps. 1 multiplied by 4 into 5 minus 3 into 6 minus 1 multiplied by 2 into 5 minus 3 into negative 3 plus 2 multiplied by 2 into 6 minus 4 into 3. Finally, determinant A is equal to minus 1. Hence, determinant A is not equal to 0. Step 2. We find the cofactor C of matrix A. The steps are as shown. Step 3. We find the adjoint of matrix A. Step 4. We find the inverse matrix. Inverse matrix is 1 over determinant matrix multiplied by adjoint matrix A. A inverse is equal to 2 minus 17, 11, minus 1, 11, 7, 0, 3, and minus 2. Step 5. Solving by multiplying matrix A inverse with matrix B. This is A inverse matrix. These are the x factors we got to find. This is B matrix, and finally by multiplying we can conclude that x1 equals to 1, x2 equals to 2, and x3 equals to 3.
Okay, so next up we will be talking about Cramer's rule. So Cramer's rule is a method to solve system of linear equations. By solving the system of linear equation with Cramer's rule, it normally consists of 4 steps, which is converting the system of linear equations to matrix form, finding the determinant and ensuring it is not 0. Then we need to replace the ith column with right hand side matrix B, which means that we need to replace the answer matrix B with the ith column with each column of the original matrix A. Then we need to find the determinant for the new matrix AI and solve by finding the quotient of determinant of AI by determinant of A and repeat for each variable to be found. This might be sounding a bit confusing, so let's look at some example. Okay, here we were given the following system of equation. x1 plus x2 plus 2x3 equals to 9. 2x1 plus 4x2 minus 3x3 equals 1. 3x1 plus 6x2 minus 5x3 equals to 0. The equation can be converted to the matrix form. We will get the A matrix 1, 1, 2, 2, 4, negative 3, 3, 6, negative 5. Then the X matrix, the x1, x2, and x3. And then we will have the B matrix, the answer matrix, the 9, 1, 0. As stated before, we need, after converting to the matrix form, we need to find the determinant and ensure that it is not 0. So let's find the determinant of matrix A. Here we will be looking at the first row of matrix A. So we will have 1 times 4 times negative 5 minus 3 negative 3 times 6. Okay. Then for the second part, we will have negative 1 times 2 times negative 5 minus 3 times negative 3. Then for the last one, we have 2 times 2 times 6 minus 3 times 4. And then which we will get this result, which will have 1 times negative 20 minus negative 18, which we will get negative 2. Negative 1 times negative 10 minus negative 9, which we will get 1. And then 2 times 12 minus 12, we will get 0. So the determinant of A, of matrix A, is negative 1. And negative 1 is not equals to 0. So this concludes the step 1 of the Cramer's rule method. So next, we need to change the ith column with the matrix B. Okay, so this is the original matrix A, 1, 1, 2, 2, 4, negative 3, 3, 5, negative 5. So let's change the first column of matrix A first. So as you remember, the B matrix is 9, 1, 0. So by exchanging the first column with matrix B, we will have 9, 1, 0 at the first column of A, matrix A. We will have 9, 1, 2, 1, 4, negative 3, 0, 6, negative 5. This matrix, we will call it as A1. Okay, then we need to find the determinant of matrix A1. The determinant of matrix A1 can be found as shown. As seen here, we are also looking at the first row of matrix A1. So we will have 9 times 4 times negative 5 minus negative 3 times 6, then negative 1 times 1 times negative 3 negative 5 minus 0 times negative 3. Then we will have positive 2 multiplied by 1 times 6 minus by 0 times 4, which we will get 9 times negative 20 minus negative 18 minus 1 times negative 5 plus 0 plus 6 times 6 minus 0, which we will get this, and then the resultant we will have negative 18 plus 5 plus 12. And the determinant of A1 we will get negative 1. So according to the Cramer's rule, we will get that the x1 would be the determinant of A1 divided by the determinant of A. Then, as shown here, we will have negative 1 divided by negative 1, which is equals to 1. So this is how we use the Cramer's rule to find our answer. So as shown here, we have already found x1, which is equal to 1. Let's go on to the next step. Let's find x2. So for x2, we need to substitute the second column of matrix A. As shown just now, when we was finding x1, we substitute the first column of matrix A with matrix B, but now it is the second column. So we will have matrix A2 as 1, 9, 2, 2, 1, negative 3, 3, 0, negative 5. So similar to just now, we need to find the determinant of matrix A. As shown with the step here, we will get the determinant of A2 as negative 2. So the answer for x2 would be A2, the determinant of A2 divided by the determinant of A. And we will get negative 2 divided by negative 1, which is 2. So with this, we have found our first variable x1 and second variable x2. So similar to just now, we will just need to go on with the same step to find x3, but exchanging the matrix B into the third column. As you can see, the third column is substituted. So now we have our matrix A3, 1, 1, 9, 2, 4, 1, 3, 6, 0. So by using the similar step shown before, we can find the determinant of A3, which we will get negative 3. So the answer for our variable x3 would be the determinant of A3 divided by determinant of A, which is negative 3 divided by 1. And there we go. We have all three values for the variable x1, x2, and x3. We have the first variable x1 as 1, the second variable x2 as 2, and the final x3 variable as 3. So that's it. That's the Cramer's rule, and I hope my explanation is clear enough for you to understand.
To summarize, in this topic, we learned on how to solve system of linear equation by using elementary row operation in Gauss elimination method and Gauss-Jordan elimination method. Other than that, we can solve system linear equation by matrix method, which are inverse matrix method and Cramer's rule. We also learned about homogeneous and non-homogeneous system, which can determine whether the system of linear equation has a unique solution, many solution, or no solution. I hope you guys can understand about this topic. Thank you for watching.